In this video, we're going to focus on the three different kinds of chemical bonds and how they form different types of minerals on our planet. So generally, we have multiple elements combining together and forming chemical compounds. And doing so, they're bonding together through chemical bonds. And by doing so, it lowers the total energy that the atom needs, and it makes them more stable overall. And we see that most of the elements on our planet like to bond together with other elements to lower their energy needs, all except the noble gases. And these are the gases here in the very rightmost column of our periodic table. Here, all of the elements within this column have 8 electrons in that outermost shell of its electron cloud, making it full. When that outermost valence shell is full, it's chemically stable. And all atoms are trying to be stable. They're trying to have 8 full electrons in their outermost shell. And this is something that's called the octet rule. And it's just, again, 8 electrons in that outermost shell of the electron cloud makes it a full shell. And then it's chemically stable. It lowers the energy needs of that atom. And almost all of the elements on our planet like to bond together with other elements to form those chemical compounds so that they can ideally have 8 electrons in their outermost shell, making them stable. All of the elements do this with the exception of the noble gases, the very right-hand column on the periodic table, because those elements already have 8 electrons in that outermost shell, making them full and stable. But when we are starting to combine these elements together and forming chemical compounds, we see that each of the elements can either gain, lose, or share its electrons during the chemical reactions that happen as they bond together. But overall, the goal is that by combining these different elements, it's going to produce more stable electron arrangements. Again, because of the octet rule, having 8 electrons in that outermost shell of your electron cloud. So we see that atoms either gain an electron from another atom, they might share electrons together, or it might give away an electron to another atom so that it's easier for it to get to 8 valence electrons, or 8 overall electrons in that outermost shell. So for some elements, like oxygen over here, because it has 6 electrons in its outermost shell, each electron represented by a red dot, it's going to be easier for it to take 2 electrons from another atom to become full and stable. On the other hand, if we look over here at hydrogen that only has 1 electron in its outermost shell, it would be a lot easier for it to give away that 1 electron than for it to gain 7 others. So depending on how many electrons are in this outermost shell, we can determine whether it's going to give away electrons, it's going to take or gain electrons from another atom, or if it'd be easier to just share the electrons between 2. So if we have multiple atoms that are either transferring, gaining, or giving away electrons, or sharing electrons between atoms, we can have chemical bonds that develop. And there are a lot of different types of chemical bonds, but we're just going to focus on 3. Ionic, covalent, and metallic chemical bonds. So with our ionic bonds, here we're going to have electrons transferred. One atom is going to give away electrons, another atom is going to take those electrons. Our second type of bond is a covalent bond. And here we're not giving or taking electrons. Instead, an electron is just going to be shared between 2 atoms. And then our third type is a metallic bond. And here all of the atoms are going to share the electrons. And the electrons are going to be able to freely move about or flow from atom to atom. So our first type of bond is an ionic bond. And this is where we have one atom losing and one atom gaining an electron. And this might be weird, so you might need to go through this part of the video a couple times to think about it. But when we're looking at an atom that is giving away an electron, it's giving away a negative particle. So that atom is becoming more positive overall when it gets rid of that negative part. But on the other hand, if we have an atom that is gaining an electron, it's gaining a negative particle, it's going to become more negative. But when we have these positive and negative ions, these ions are going to be attracted to each other. So we have what's called an ionic bond forms when we have those positive and negative atoms being attracted together, creating an ionic compound, where one atom is going to give away an electron and the other atom is going to accept it. So a good example of an ionic compound is table salt. Table salt is made out of two elements. Sodium, which is abbreviated Na, which is shown as purple in this diagram, and chlorine, which is abbreviated as Cl and shown in green here. But again, if I go back to my super fancy public salts, all of them are basically the same. They have the same fixed chemical composition. They're made up entirely of sodium and chlorine, nothing else. But for sodium and chlorine to bond together to form salt, we see that our sodium loses an electron. It becomes a positive particle, while our chlorine gains an electron. It's becoming more negative, so they're attracted together. And then they form an ionic bond. But when we have ionic compounds where we're giving away or accepting electrons to become more stable, these ionic compounds have really, really different properties now that they are bonded together than they did before when they were single elements. And again, looking at our table salt, this is a really good example of how ionic bonds change the chemistry of those atoms. So if we look at sodium, sodium by itself is something I would never ever want to be around. Sodium is super toxic and also super explosive. So if I had a small chunk of sodium about the size of a quarter and I dropped it in a bottle of water, it would create an explosion strong enough that I could possibly blow a hole in the side of an airplane. I do not want to be around sodium. But the other element in table salt is chlorine, and chlorine is just as nasty as sodium is. Chlorine was used to create a poisonous gas in the Second World War where it quickly and very horribly kills people. I don't want to be around chlorine either. So I don't want to be around sodium. I don't want to be around chlorine. They're both incredibly dangerous. But when they form ionic bonds together, they form that relatively safe substance known as table salt. This is due to those ionic compounds that chemically change the atoms involved. Our second type of bonds are covalent bonds, and here these are a lot different from our ionic bonds. Here we do not see that there's giving or taking of electrons. Instead, we're going to have two atoms combining together and sharing their electrons between two atoms. And our third type of bond is a metallic bond. With these are what create our electronics. And what makes these metallic bonds so unique is that the electrons are free to move from one atom to another. They're literally capable of flowing throughout the material. And that's because all atoms inside of the material are sharing all of their outer electrons. So this allows a material to be electrically conductive. When we plug in our phones to charge, the way that it's charging is through electricity. And electricity is just a flow of electrons coming out of the wall through our charger and into the battery. So we see that metals are capable of flowing electricity. all due to these metallic bonds inside or between the atoms. But these metallic bonds also lead to it being malleable. This means that it can be bent, especially if it's heated up. Think about those old medieval shows where they're making like swords over a hot fire. They heat it and then they can bend it because metals are malleable due to these metallic bonds. And then there are other unique properties, like the fact that we can heat it up to really hot temperatures and it's not going to turn to ash.